Okay, so this is the start of our unit on chemical reactions. So these things actually are really common. They happen all around you, but it could be that you're just unaware that they're anything special. So we're going to take 6 lessons to try to sort of understand what these are and how they're represented. We're going to use a little bit of what we did in the previous unit when we talked about bonding and how compounds are made, because most chemical reactions involve compounds. Okay, so let me give you kind of a working definition of what a reaction is, and then I'll give you some real common real life examples that you'll be able to relate to and understand. Okay, so let's use this as a definition. So it's a process. Sorry, this is going to be kind of long. Remember, you can always stop or pause me, slow me down if you have trouble keeping up. A process where atoms in elements and or compounds. Remember, everything we've done so far has involved either elements, those are the basic structures that all matter comes in, or compounds, which are combinations of those elements bonded together. So we're just talking about those same things. So elements or the atoms in the elements and compounds rearrange so that the substances after the reaction are different than before the reaction. Okay? Here's something that students get confused on, though. The atoms themselves do not change. Again, pause if you need to. So let me give you a few examples. Again, these are, I tried to find ones that I thought you would all at least be somewhat familiar with. How about cooking? Not just talking about heating things up, but cooking. In particular, things like baking. You gotta agree that what you end up with after you bake, let's say, raw bread dough, is different, right? The bread is different than the dough. It's got the same atoms in it, but a chemical reaction happens during the baking process. Rusting. So if you have a piece of iron, steel, something like that, over time, especially if it gets wet, rust happens and you have something entirely different, this flaky red stuff that looks totally different and acts totally different than the good solid steel that you started with. Rotting. Kind of a gross one, right? Rotting or decomposing, same kind of thing. If you have a compost pile in your yard somewhere, you put in the raw materials, things like grass and leaves and some vegetable clippings and things like that. And then after a series of months, maybe a year, you have totally different stuff, actually good compost for using in the garden. Burning. You know, just picture wood burning, let's say in a fireplace. What you end up with at the end, which is what we call ash, is completely different than the wood that you started with, right? Digestion is also a chemical reaction. That's the acid in your stomach reacting with the food that you eat, making something entirely different. And fermenting. Okay, so there's just a few examples of ones. So let me do an example. I'm going to do a demonstration here for you of a couple chemical reactions so you can kind of get a look at some simple ones and what they look like. Okay, so let me get it set up here. Okay, I think my first reaction here is going to be the most impactful, the one that's easiest to see. So I'm going to start with a solution. That means I've mixed with water a compound called lead nitrate. Okay, so I'm just going to pour a little bit of that into this clear cup here. It's just a plastic cup. Doesn't take a whole lot. And then I'm going to take another solution of potassium iodide. Now there's a compound that you can relate to because we talked about when we bond a metal like potassium with a non-metal like iodine, we get a compound called potassium iodide. And if I dissolve it in some water, this is the solution that I get. You'll notice it has slightly different color. Does it look a little different? Kind of hard to tell on the camera. Okay. So these are the two materials that I'm starting with. Okay. All I'm going to do is I'm going to pour one into the other, and you'll see very easily that we have a different substance after the reaction than before. Kind of dramatic, wasn't it? Now, typically in my class, we do this reaction in the lab. Really disappointed that you can't be back there doing it yourself because it is very dramatic. So that's what we have here. So definitely a different substance after than we had before, right? Let's do another one. Okay, I have a couple additional solutions here, and these are ones that you know. So sodium bicarbonate is the chemical name that most people refer to as baking soda. I dissolved a little bit in water, so that's a sodium bicarbonate solution. And this is vinegar dissolved in water. Chemical name would be hydrogen acetate solution. I'm going to pour that into the other cup. Now you've mixed baking soda and vinegar, probably most of you, right? This isn't going to be quite as vigorous a reaction as if I had used solid baking soda, but we're still going to be able to see it, I think. See what happens here. Watch closely. Okay, can you see those bubbles starting to form there? Put a little different background on there. There they are. You can definitely see the bubbles forming. If I swirl a little bit, the bubbles will ramp up a little bit and then they'll die down. So those bubbles definitely were not in the substances before the reaction. And when we get a change like that, that's what we refer to as a chemical reaction. Okay? So let's talk a little bit more about what we saw there before and after and how we represent that. So I'm going to introduce you now to the idea of a chemical equation. Think about equations that you know from math class, something with an equal sign. And in math, it takes you a few years to get used to the symbols that you use. And that's exactly what we're going to do here with a chemical equation. We use different kinds of symbols than they use in math, but it is still just a symbolic, giving you a description of what it is, a symbolic representation of a reaction. Every equation kind of has certain parts. I want to show you what those parts are. Okay. We start, with what we call listing the reactants. Those are the things that we have before the reaction. So any substances before the reaction are called reactants. And the products are the substances after. The reaction. So an equation always takes this form. We write whatever the reactants are, and then we use an arrow. We don't use an equal sign, we use an arrow. Basically kind of saying that it turns into something new in this direction. And what it turns into, those reactants become new substances called the products. Okay, so this is the form that it takes. So let me show you the two equations that will go along with the reactions that I just did as a demonstration. The first was the lead nitrate and the potassium iodide reacting together. Okay, now I would not expect you to know this part, but I'm just going to show you what the reactants and the products look like. So the lead nitrate looks like kind of a complicated formula. It's got some formats there with the parentheses that you're not familiar with. We didn't do those particular kinds of formulas when we did it in the last unit, but that's okay. So this is our lead nitrate. This one you should know though, potassium iodide. That's one potassium atom bonded with one iodine atom. Okay, so you see we use a plus sign just like we do for addition when we do math, right? So these are the two reactants that we had. Now they were both dissolved in water, but the water was just there to kind of move things along and let things mix nicely. But those are the two actual chemicals that reacted together. Okay, and what do we get when we're done? Well, what we had was that yellow substance was lead iodide. And there is the formula for lead iodide, PbI2. And we have potassium nitrate. I'm going to squeeze it in here. I'm running out of paper, but I think I can fit it. KNO3. K is a potassium. NO3 is called nitrate. Okay. So in this one, oops, these are the reactants. And these are called the products. So I mentioned that the yellow stuff that we saw in that reaction was the lead iodide. You could not see the potassium nitrate because it dissolves in water and we're not able to see it. Okay? So there's a little bit more I need to do with this particular equation, but I think for right now, just so I'm not confusing anybody, I'm not going to do it. But in the next lesson, I'm going to come back to this and I'm going to show you why we need to do a little something with that in order to show exactly what's being represented. But I don't think it's necessary right now because we can clearly see the reactants and the products, and that's really all I want you to be able to do. Okay, so let's do an equation for that other reaction. That's the solutions of baking soda and vinegar. Okay, so we'll write the reactants, then we'll write the products. Okay, so the two reactants that we have were sodium bicarbonate and hydrogen acetate. I'm going to write these kind of small because the formulas are a little longer. Okay, sodium bicarbonate is Na, you know that is sodium. Bicarbonate is HCO3. That's a hydrogen, a carbon, and 3 oxygens. And then we combine that with hydrogen acetate. It's got a hydrogen and then an acetate, C2H3O2. Again, a little bit more complex of a formula than what you're used to. You might be thinking, well, why are we writing it that way? Well, let's not get into the details. As long as we recognize reactants and products and can write the equation, I'm good. Here's our arrow. That indicates that now the reaction's happening. So we start with these two reactants, and what do we end up with? We end up with things just kind of changing positions. So instead of the hydrogen with the acetate, we have the sodium with the acetate. So that's NaC2H3O2. And then we have the hydrogen bonded with the bicarbonate. So we write H2CO3. Again, trying to squeeze it in the paper that I have here. So again, we have before the reaction, before the arrow, this is all I want you to be able to recognize. To the left of the arrow are the reactants, and to the right of the arrow are the products. Okay? So the reaction itself is kind of indicated by that arrow there. Right? So I think this is a good place to stop here. And then in the next lesson, we'll get into a little bit more detail about what's actually happening with the atoms, or more importantly, maybe what's not happening with the atoms during the reaction. Okay? All right, so let's see how this goes when you apply this to the worksheet that I have ready to go for you today. Good luck.